Okay, if we keep going, you may have learned about relative, and another word for relative is local. Relative maxes. Maximum is the singular, maxima is the plural. So what you're looking for is the highest point in an area, and it has to be in an open interval to be a relative max. You have to actually have graph on both sides of it, so you can't just come in and stop, because there's no open interval right here where this is the highest point. You have to have both sides. So you're looking for a peak. You can see the open interval right here. You're looking for some kind of peak, a highest point in an area. Now a graph can have no relative maxes or 10 relative maxes. There's no limit on this. So we're just looking for a high point, a peak. So if we come along here, this at x equals negative 0.75 could be a relative max. It's the highest point in an area. So I'm going to say x equals negative 0.75. I'm going along again. The other high point is right here. Some people wonder, can a cusp be a relative max? Yes. It's a high point in an area. So this cusp happens at x equals 3. So this graph has two relative maxes, maxima. For a relative min, we are looking for a low point. So the bottom of a valley. Okay, come along here. This would be a relative min had that point actually existed, but the graph is not defined at x equals negative 4, so it can't be a relative min. You come along. This is a low point, but it doesn't have both sides, so you can't use that point. Here, this is the bottom of a valley or a crevice. It is the lowest point in an area, in a locality. So x equals 1 is where there's a relative min. If you keep going along, that is the only one. So this graph has one relative min. So relative goes along with local, local max, local min, relative max, relative min. The words that go with absolute max and mins are global. So it is the absolute highest point that the graph can reach, and we're going to look for the x values. So the highest this graph goes, some people might think is this right here, but it isn't, because over here the graph keeps going up forever. So this graph actually heads towards positive infinity. Well, that means that there is no absolute max. Okay, an absolute min, I'm looking for little arrows on the graph. There's no place where it goes down to negative infinity. So this graph is going to have a lowest point, and it's right here. So the absolute min happens at x equals 1. And normally for absolute max and min, if they ask you what is the absolute max, what is the absolute min, they're talking about the y values. If they want to know where they are, they're talking about the x values. So later in the class, if I ask you what's the absolute min, you would say it is negative 1, 2, 3.5. So negative 3.5. You're talking about the y value. The last thing I ask for in a graph is what are the intervals where this graph is continuous. So it's kind of like giving a domain, but not really, because you can actually, if you use unions in a domain, you can mess up what's going on with continuity. So don't use your union symbol, and I'll show you the difference as we go. So again, we're listing x intervals. So my graph exists all the way out towards negative infinity. Now you can't equal negative infinity, so it gets a parenthesis. And it's continuous, and the basic term for continuity we're going to use right now is you can draw it without picking up your pen or your pencil. So I'm coming in from negative infinity, and I get to negative 4, and I would have to pick up my pen, so from negative 4. Now, your graph never actually equals negative 4, so I have to use a parenthesis, not a bracket. Okay, now I'm going to pick up my pen, and I'm going to put it back down at negative 4. So my next interval will start at negative 4. I'm traveling along all the way until I get to 0. Now, for continuity, you can have be continuous on a closed interval as long as it comes in and actually touches the point right there. So, and I'm going to get into fancier definitions later, but we will go from negative 4 to 0. It touches 0, so I'm going to have a bracket. For my next interval, I did have to pick up, I'm coming down here. I'm going to start at 0, but it looks like my graph isn't defined down here at x equals 0, so I'm going to use a parenthesis. Okay, come along, don't have to pick up my pencil, don't have to pick up my pencil, don't have to pick up my pencil, all the way till I get to here. So that's at 1, 2, 3, 4 at x equals 4, and it's a solid circle, so from 0 to -4 bracket. Now if I had used union symbols, let's just take these two intervals for example. If I'd said -4 to 0, union with 0, this is a +4, like this union symbol joins these two. Now because 0 is actually included in this, if I used union, that would mean I was going from -4 to 4, which is not correct. Now -4 all the way to 4 is in the domain, because x equals 0 is in the domain. The graph exists there, but we have a continuity issue at x equals 0 because we had to pick up the pencil. So those are a few of the attributes we'll be looking at for graphs.